So the second method of preparation of alcohols is from carbonyl compounds. Carbonyl compounds. What are carbonyl compounds? Carbonyl group containing compounds. Like this. This is the carbonyl group. So carboxylic acids, aldehydes, ketones, esters, all this will come under carbonyl compounds. So first one will take reduction of aldehydes and ketones we'll see. By reduction of carbonyl compounds, we can produce alcohols. So under that, you see first one is reduction of aldehydes and ketones. Reduction of aldehydes and ketones. So the general examples will write. Suppose this is the aldehyde we can take. Aldehyde. So if it reacts with hydrogen, so addition of hydrogen in the presence of a catalyst. So it's like catalyzed hydrogenation, we can say, in the presence of platinum or palladium, Pd, or nickel, Ni. So these three will come under a single group. So we know that in the case of D block elements, nickel group, if you see, nickel, Pd, Pt. So it all belongs to the same group. So all will act as catalyst for reduction. So reduction means addition of hydrogen, right? So you can write aldehyde, proper aldehyde. So what will happen? These two hydrogens will be added to the carbonyl group. So this will become RCH2OH. So this is a alcohol. What type of alcohol we got? Alcohol is attached to a carbon which is in attachment with only one carbon. So this is primary alcohol. So reduction of aldehydes will give primary alcohol. So next one, ketones we can say, aldehydes and ketones, how they are reduced. If we take a ketone, ketone will be double bond O R prime plus H. I mean, in the case of, you can reduce with the catalytic hydrogenation, or by reducing agent also you can use. Reduce this ketone. So I can say like this. In the presence of reducing agent, sodium borohydride NaBH4. Sodium borohydride. So this is the reducing agent. Sodium borohydride is one of the reducing agent. Reducing agent. So reducing agent means the agent or the chemical species which will reduce the compound. So how it is reducing? By donating its hydrogens to the respective ketone. So what will happen here? The ketone group will become alcoholic group. So here hydroxyl group is added, one hydrogen is added. This is alcohol. So this will become secondary alcohol, right? So I can say secondary alcohol. Because the carbon is attached with two carbon. This is secondary carbon, right? The secondary alcohol. So by the reduction of aldehydes and ketones in the presence of catalytic hydrogenation, by catalytic hydrogenation, otherwise in the presence of a reducing agent like sodium borohydride. Another important reducing agent what we can know is lithium aluminum hydride. This is most powerful than sodium borohydride, and it is expensive also. Lithium aluminum hydride. This is also another example. This is also a reducing agent. Lithium aluminum hydride, another reducing agent, you can say. Reducing agent. You can write like this. So next one, we have two more carbonyl compounds, right? So I'll write that as B. You can take it as B. Reduction of carboxylic acids and esters. Carboxylic acids and esters. So we'll see here. Carboxylic acids means RCOOH. RCOOR, esters. So carboxylic acids is RCOOH. Ester is RCOOR, right? So this is acid, carboxylic acid. This is ester. So generally, the acids and esters cannot be reduced by sodium borohydride. This is the important point we have to note. So sodium borohydride can't reduce acids and esters. So I can write instead of formula, we'll write carboxylic acids only, we'll write reduce carboxylic acids and esters. So it cannot reduce. So then we have another reducing agent which is called lithium aluminum hydride. So we'll use lithium aluminum hydride. Lithium aluminum hydride. Lithium aluminum hydride. So this is the strongest reducing agent. This is the strongest reducing agent. So it can easily reduce either alcohol, either carboxylic acid or ester when compared to sodium borohydride. So this is the important point what you have to note. So in such case, we can say, the reducing ability of lithium aluminum hydride is more than the sodium borohydride, because this can be used for anything, for reducing aldehydes, for reducing ketones, for reducing alcohol, the carboxylic acids, or for reducing esters also. But it is expensive thing. That is one more important thing what you have to reduce. So then how it will reduce? So I can write RCOOH. So this we will write in the form of RC double OH. Right? In the presence of lithium aluminum hydride, LiAlH4. So this is the first step, and hydration, hydrolysis, we can say. So the entire mechanism will happen in two steps. This reduction will form alcohol, CH2OH. OH. So here it is reduced. So it has formed the primary alcohol. So then, as I said already, lithium aluminum hydride is used specifically for producing certain alcohols because it is expensive. So in the case of preparation of alcohols from the carboxylic acids, one more method is followed, where it is converted into an ester. How esters are found? By the reaction of carboxylic acids with alcohols. So acid, if it reacts with alcohol, it will form the ester. So we know R, C double bond O, O, R prime. So this is the ester. So ester can be easily reduced by catalytic hydrogenation, by addition of hydrogen in the presence of catalyst. Catalyst means again nickel, RPD, RPT. So what will happen? This also directly, ester can also be easily reduced by lithium aluminum hydride. But I told you sodium borohydride cannot reduce the esters or carboxylic acids. But in the presence of catalyst, easily by addition of hydrogen, it can be reduced to respective alcohol. What will happen now? The respective alcohol will form. So what will happen is RCH2OH plus R prime OH. So see, yield is more. Two types of alcohols are produced, right? So catalytic hydrogenation will help in the formation of respective alcohols with good yield. So highest yield will get. Here also, yield will be more. Yield of alcohol is high. In the case of lithium aluminum hydride uses for the production of alcohols from carboxylic acids. So this is how we can produce alcohols by reduction process of carboxylic acids and esters and from aldehydes and ketones. Okay. So next we will move to another topic. Third one, by using Grignard's reagent. By using Grignard's reagent for the formation of alcohols. So what is Grignard's reagent? Alkyl magnesium halide. Alkyl, R means alkyl. Magnesium, Mg. Magnesium halide. X is halide, right? Any halogen like chlorine, bromine, iodine, like this. So how? So again from carbonyl compounds. Carbonyl compounds means RC double bond O, right? So from carbonyl compounds only again. So carbonyl compounds. Nucleophilic addition of, so you can write one statement here. Nucleophilic addition of Grignard's reagent, RMGX. I'll write instead of Grignard, RMGX on carbonyl group, on carbonyl compound, followed by hydrolysis. Followed by hydrolysis. Leads to formation of alcohols. So this statement, if you see, according to this statement only, the mechanism of reaction will happen actually. So that we are going to see now. So we said carbonyl compounds will interact with Grignard's reagent, right? So we'll write the carbonyl group. Carbonyl group is this one. So what will happen if it interacts with alkyl magnesium halide? That is RMGX. RMGX. So we'll write first general equation. So this is alkyl group, magnesium and halogen. So it will have a partial positive charge. The charge separation will be there between the alkyl and magnesium groups. So it will contain a partial negative charge. So if you take this particular carbonyl group, so what will happen? This double bond electrons will shift here. So that partially for temporarily, even this carbon will attain a positive charge, right? If it go like that, it will lose the electron, right? Per electron. So it will partially, it shows negative charge, oxygen, because of this rearrangement. So what will happen later? It will form an adduct like this. So here what will happen? If it is like this alkyl group will go and combine with this carbon, interact with this carbon. Then this oxygen, there will be interaction between this oxygen and the magnesium center. So this will happen. How it will happen? We'll write. See, this carbon is attached with R, right? So I can change the color of the compound R. So R came here, right? Then what happened? This oxygen is combining with magnesium halide. So this will contain negative charge, this will contain positive charge. So you can show this as an addition product or adduct, we can say, because it is nucleophilic addition, right? We said it is a nucleophilic addition. So here, this is called adduct, we can say. It is called adduct. So this adduct will undergo hydrolysis in the presence of water molecule. HOH we can write. So what will happen? One H will go and bind with the oxygen. OH will go and bind with the magnesium now. So the final product will be like this. CrOH. Right? This is alcohol plus MgOH. So this hydrogen has bound to this particular oxygen and OH has bonded to magnesium. This is what happened here during hydrolysis. This is hydrolysis. Second step. This is, so we can write nucleophilic addition of Grignard's reagent. So this step is called nucleophilic addition, you can say. So this one is first step. This is second step, hydrolysis, and you got the alcohol and hydroxy magnesium halide. Hydroxy magnesium halide. Magnesium halide. You can say like this. Okay, ma? So here what we are going to see is another one is each carbonyl compound, if it interacts with the RMGX, Grignard reagent, what type of alcohol is produced? Suppose if methanol reacts with the RMGX, methanol means HCHO, methanol and formaldehyde we can say. So formaldehyde, if it reacts with the alkyl magnesium halide, what type of alcohol is formed? If alkyl, I mean ethanol, ethanol means not alcohol, ethanol, AL. So ethanaldehyde, if it reacts with the RMGX, what type of alcohol will form? So you will get secondary alcohol. If ketone reacts with RMGX, what type of alcohol you will find? So tertiary alcohol is formed. So these three reactions we will discuss. So that will be the conclusion of this particular topic by interacting with the Grignard's reagent, how carbonyl compounds are forming the alcohols. First one I will write formaldehyde. H C double bond O H. So this is called as HCHO. You can write. So this is formaldehyde. Formaldehyde or methanol. Methanol. Al, right? Either this name or this name you can write. So what will happen? So plus RMGX. Or you can take anything, no problem. Any alkyl group. MgX. So what will happen? This is the nucleophilic addition we know. So what will happen? R will go and bind with the carbon. Mechanism I have shown, general mechanism. O will come and bind with the Mg. So what will happen? Every time no need to show. So this will happen like this. So already this will have a partial positive, negative charge. We have seen already this one. Partial negative charge will be there. This will have a partial positive charge. So what will happen? H, C, R, H, O, Mg, X. This is the adduct, right? Addition product, nucleophilic addition product. So upon hydrolysis, what will happen? HOH. So what will happen? This hydrogen will go and bind with this oxygen. OH will go and bind with magnesium. So finally we'll have a product of C, H, I mean CH2 we can write simply, R, CH2, O, H plus Mg, OH, X. So this is primary alcohol, right? This is primary carbon. So this is primary alcohol. So primary alcohol is produced by methanol interacting with the RMGX, Grignard reagent. So this is the first one. So primary alcohols are produced from methanol. So this is one you can take. Second one, suppose B. If any alcohol is there, I mean any aldehyde is there, not formaldehyde, generally higher aldehyde. As I can say, simple aldehyde will take, ethanol will take. C double bond O H. So this is ethanol, right? So one more carbon is there. So proper aldehyde, this is, you can say, not simple one, so little higher one. So what will happen? So same thing, RMGX. So what will happen? Adduct will form R, C. This will, for difference, will keep it R prime H, O, Mg, X, right? So this is the adduct. So upon hydrolysis, what will happen? The same thing, it will form a secondary alcohol, R prime. So this is one more alcohol, this is one. This is hydrogen, here OH plus Mg, OH, X, right? So hydrogen will go here. I told you, hydrogen will go here. OH will go and bind with magnesium. So this is secondary carbon. So this is called secondary alcohol. This is secondary alcohol. So finally we'll see, if you use ketone, what will happen? C double bond O, R, R prime plus R prime, R double prime MgX. For showing the difference between the alkyl group, we are writing like this. So nucleophilic addition of aldehydes with the RMGX will form an adduct definitely. So that adduct will be like this. We'll write downwards because space is not sufficient here. Yeah. So what will happen? So this will interact with R, R prime, R double prime. Okay. O, Mg, X. This is the adduct. Right. So again, this will undergo hydrolysis. So it will form a tertiary alcohol. So you can write simply R prime, C, R, this is R double prime, OH plus Mg, OH, X. Mg, OH, X. So you can write like this. So this is tertiary center, right? This carbon is attached with 3 carbon centers. Alcoholic carbon is attached with 3 carbons. So tertiary alcohol, tertiary alcohol. So this is the formation of tertiary alcohol using the Grignard's reagent upon ketones. So this one, so you have once again you can review methanol reacting with RMGX will form primary alcohols. Primary whole cell, simply aldehydes. Remaining aldehydes, any aldehyde you take, it will form secondary wholes. Wholes means alcohols. Ketones will form tertiary alcohols. Wholes. Understand? So this is the